Okay, in today's lecture we are going to study cache architecture. The cache architecture, as we know, the cache memory can be implemented by static RAM because the access time is faster or very less as compared to DRAM, the dynamic random access memory, because DRAM needs refreshing of the content, whereas static RAM do not need refreshing of the content which is stored. So that is why static RAM is faster as compared to dynamic RAM, and we use static RAM as a cache memory. Okay, the cache memory is faster and it is of three type of architectures. First one is associative cache, second one is direct mapped cache, and third one is set associative cache. Okay, so three type of contents are there, three type of architecture of cache memory is there. Okay, first we study about associative cache memory. In the case of associative cache memory, the associative cache memory, you can say it works in a pattern similar to the paging concept or the demand paging. Here we have got main memory. Main memory has got number of blocks, and each block is of size 8 byte or 8 byte or 16 byte. So the content that is being transferred between main memory and the cache memory, the unit of that content will be block. So we transfer one block at a time from main memory to the cache memory. Okay, block size is generally 8 bytes. Okay, so associated with the cache memory there is one more memory, that is called tag memory. Now what is the tag memory and how they are connected, how the overall functioning is done, that we are going to study in this lecture. As we know, when we have to transfer the data from main memory to the cache memory, the transfer will be done in terms of block. So the entire block, we cannot transfer 1 byte from main memory to cache memory, but the unit of transfer is block. So what we do is we transfer the entire block from main memory to the cache memory in one time. Okay, now the CPU addressing is logically seen like this. The CPU address, which is generated by the CPU to fetch out the content from main memory, and the address is divided like this. It is considered as the two components, one is block number and the second one is byte number. Okay, so the CPU address, suppose the CPU address this particular out of the 8 number of bytes, CPU want to address this particular byte. Okay, suppose block number is, this is 00 block, this is 01 block, so the address will be like this: 01 block address and 01234 04 byte address, block address, byte address. Inside the block number 01, I want to access byte number 4. This way the CPU performs the addressing inside the cache memory, inside the memory and similarly in the cache memory. Let us assume one example, a machine with 16-bit addresses. The address division is like this. 13 bits will be utilized in block number, and 3 bit will be utilized as a byte number or byte address. Okay. With the 13 bits, we identify the block in the main memory, and with the last 3 bits, we identify 2 to the power 3, that is 8 bytes inside that block. Okay, within that block. It is like this, as we have seen. These are the blocks. So the 13 bits we will use to identify number of block, and those 3 bits we use to identify which byte out of the 8 bytes. Okay, it means that with this in this architecture, in this particular architecture, we may have 2 to the power 13 number of blocks in memory. Okay, and each block has 2 to the power 3, that is 8 bytes. Okay, so the whole memory, you can say the whole memory, this is the memory, main memory. The main memory has got total 2 to the power 16 and 2 to the power 13, 2 to the power 13 number of blocks, and 2 to the power 3 number of bytes in each block. It is like this. So we transfer one block from main memory into cache memory. This we already discussed. When we want to search a block, if it is there in the cache memory or not, we always search that block with the block number only. Okay, if the block number is found this area, if the block number is found in the memory, in the cache memory, okay, if the block number is found in the cache memory, then we can reach out to the particular byte which is required. Okay, for that, in cache memory we have small additional locations which we contain this block number. For n number of blocks, we have n number of additional fields, that is called tag field, or this memory where tag fields are there, it is called tag memory.